Is it holding? Yeah, I think it's okay now. Okay, so here's what we just did, but we only did it with 2. So delta x times f of x1 plus delta x times f of x2 plus delta x times f of x3 plus delta x times f of x4 plus delta x dot 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 delta x f of xn. Does it ring a bell?
Is it the sigma?
Excellent. From I equals 1 from the first subinterval till what is the last one? N. From what? Exactly what we just said. Delta x, which is constant, times f of xi. When I is 1, delta x times f of x1. When I is 2, that's why I cannot use x here for the index, ever. When I is 2, plus delta x f of x2. When I is 3, plus delta x, base times height, plus base times height, plus base times height, plus base times height. And that's the sum. This bears the name of the person who invented it, Riemann. It's the Riemann sum. Of course, this is a constant. You can put it in front if that's what you want. But this shows that this is the area of rectangles. Area of rectangles. Base times height. Okay, now we are ready to calculate the exact area under f of x equals x squared on 0 to 2. Of course, using the limit of the Riemann sum. Okay, we have 3 preps. 3 preparations. Number 1, delta x, always first. 2 minus 0 divided by n. Of course, we have n subintervals. So delta x is fixed 2 over n. The second prep, so this was this. Second prep is this. What does xi really mean? So we have to analyze that. This is 0 and this is 2. That's our interval. Okay, so delta x, and I get to x1. Delta x again, and I get to x2. Delta x again, and I get to x3. Dot, 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 I get to xi. Because I goes from the first one to the last one. Xi plus 1. Xi plus 2. Dot, dot, dot. Till the last one. So what is the formula for xi? Xi is 0 plus delta x, delta x, delta x. Maybe I should, let me just present x1 first, so you see what the pattern is. X1 is 0 plus a delta x. X2 is 0 plus 2 delta x's. X3 is 0 plus 3 delta x's. And now I want xi. How do I represent xi?
Would it be 0 plus I delta x?
Exactly. Excellent. That's what it is. A sip of water. Exactly. 0 plus I delta x, which means I times delta x is 2I over n. So this is prep number 2. So for our example, delta x is 2 over n, and xi is 2I over n. So I have the first prep, I have the second prep, now I need the third prep. Before I even write all this, I need the first prep, which is delta x. I need the second prep, which is to discover what xi really equals to in our problem. And now for our function, I have to plug in xi. That's my third prep. And then I can put everything together. Okay, so number 3. F of xi. Remember, f of x is x squared. Okay. Which is 4I squared over n squared. With all these preps, I am ready now to find the exact area. No approximations, done. So final step, area equals the limit as n approaches infinity from the sum from I equals 1 through n, delta x, 2 over n, times f of xi, 4I squared over n squared. Okay, let's stop for a second if you have any questions. Oh, you should always stop me if you have questions, you know that. Are we okay?
Is this all we do, or
No,
Okay,
this
numbers
is the beginning.
Mm-hmm.
We haven't finished. We have to find a number. We are looking for the exact number. We got 3 numbers so far. We got 1, we got 5, we got 2.5, none of which is the correct answer. They're all approximations. Now here, this is the exact area. We have to find a number that is the exact area using the limit of the Riemann sum. We needed the first prep, first step. We need the second prep, step 2. We needed f of xi, step 3. And now I put everything together.
Will we be asked to find the left, middle, and right approximation?
Yes.
Okay.
Yes. We're going to look at examples in a minute. If you want to, if we want to choose other examples, of course, yes. Okay, like always, remember I say factor simplify. I'm looking at all this. 2 is a factor, 4 is a factor, n is a factor, n squared is a factor. They're not depending on I. So all this goes outside. It's all a factor. It's a number, whatever it is. It doesn't depend on I. So then I have limit as n approaches infinity from 8 over n cubed, and this is what I want. Why? Because I know that this, we just studied that, is n plus 1, 2n plus 1 over 6. So it's done. Gone. So this is limit as n approaches infinity. Don't erase it like that, I'm making a point. N cubed times n plus 1, 2n plus 1 divided by 6. And we have tools for this. We have L'Hopital's rule, we have simplification, we have who knows. So, one more time. We put together the pieces, the delta x and the f of xi, because they are all factors. I don't see them addition or subtraction. So 2 and 4 and n and squared, they're all factors. They go out. And that's what I want. Because as you know, I only have 4 formulas. Where are my formulas? I don't know. Oh, okay, I found it. Okay, that's all I know. The sum of 1, the sum of I, the sum of I squared, and the sum of I cubed. Nothing else. We are very limited. So after I put all this together and I realize that this goes out, I know that what this equals to. The sum from I equals 1 to n from I squared is this. So I replace it. Next, of course I simplify. Of course I simplify. I take 4/3 outside, like I always do with something like this, and then limit as n approaches infinity. I distribute here. I have 2n squared plus what? 3n plus 1 over n squared. There is not even a need to continue, or if you want, we can. It's infinity over infinity, L'Hopital's rule. We know what we are going to get. What are we going to get from here?
Infinity. Oh wait, what are you asking?
So what is this limit?
The derivative of the top over the derivative of the
Correct.
bottom.
So the top is 4n, the denominator is 2n. I simplify, and what do I get? Because at some point in time, this will go away too. So it's 4n.
2.
Yes, exactly. Leading coefficient over leading coefficient. So the exact answer is this. It's not 1, it's not 5, it's not 2.5, it's 8/3. And this is the mechanism. Of course, we are limited. One more time. We can only illustrate with quadratic functions, cubic functions, and linear functions. If you ask me to determine this exact and you give me tangent x, I'll say sorry. You can only give me a linear function, quadratic, cubic. If you give me f of x equals arctangent x, find the area between 0 and pi, or pi over 4, I'll say sorry. I can, but not with this method.
I'm a little confused as to, like, I understand why we do L'Hopital's rule, but why'd you get 8/3 if it's 4n plus 3 over 2n when you differentiate it?
So it's 4n plus 3, correct?
Yeah.
And the denominator is 2n.
Mm-hmm.
And I differentiate again, and I get 4. I differentiate again, I get 2. 4 over 2 is 2.
Yeah, sorry.
No worries. So 2 times 4 will be 8, and 3 is 3. Any questions? Any questions here?
This is kind of like, I don't know, it might be a dumb question, but when do we drop the limit? Like, in what step do we have to not write it anymore?
Okay, so...
Like, once it's finally 4 over 2, or can we drop it as soon as we do L'Hopital's rule?
Oh, okay, so let me erase this and continue. So you didn't see this. So let's continue. So we're applying L'Hopital's rule, and we have 4/3 in front. So infinity over infinity, I differentiate the top. So I get 4n plus 3 divided by 2n. It's still infinity over infinity. I have 4/3 limit as n approaches infinity. It's infinity over infinity, so the numerator is 4. When I differentiate, the denominator is 2. So then 4 over 2 is 2. The limit of 2 is 2. So 4 over 3 times 2 equals 8 over 3.
Okay, I was just curious, so like when I'm
Yeah.
showing my work.
Yes,
then I
absolutely.
would-
Perfect. Yes, absolutely. I completely agree. Any questions? Any questions? Is there anything else, or can I continue? Okay, so now let's invent another function. Any function you want to invent. Linear, quadratic, not linear, of course, too simple. Quadratic or cubic, and a more sophisticated function. Nothing is really sophisticated when it comes to quadratic and cubic. Any function you want, and give me an interval. If you want to be nice, but you don't have to, you will use 0 to something. But if you want us to work a little bit harder, use anything else, like, I don't know, 3 to 10. If the interval starts at 0, of course it's easier, but if you want to start with any other number, we can. So let's choose any function you want, but only quadratic or cubic, and let's illustrate step by step how we get the number. That is the exact area under the graph. Now, I wanted to explain one other thing. That the area under a graph, if the function looks like this is a negative area, which is much bigger than this positive area. So the result can be a negative area. This is possible. Good. So any function you want to come up with. But don't say tangent or anything else but cubic or quadratic. To illustrate again, the limit of the Riemann sum.